Hey there, it's Joseph from RoboFlow, and today I'm going to walk through a common question. Which augmentation steps should I use if you're using aerial data? And when we say aerial data, we mean data captured from above. So this could be images from a satellite, Google Earth, maybe a drone, any sort of aerial perspective looking down. A lot of these recommendations may apply. For today's example, I'm going to walk through an aerial data set that we call the Ariel Maritime drone data set. This data set is a series of actually pretty small, just 74 source images captured over top of a lake. So we have annotations of boats, boat lifts, docks, jet skis, things like that. It's on public.roboflow.com, and you can click fork and it'll copy directly to your account if you want to play with this data set. I've gone ahead and done that. So on my RoboFlow account, and I'll go ahead and move myself down here, I can pull up a couple of these images so you can see. So you'll see I have a sense of some of the lifts here, some of the boat docks, boats out on the water, these various perspectives. And so the question becomes, if you have an aerial data set, how can you get the most out of your data without having to collect a bunch more? Now, to be clear, collecting more source imagery is always going to improve your model and is certainly recommended. But how can you get the most from the data you've already collected? That's where augmentation comes into play. It allows you to get more with less out of the images in your existing data set. So if I'm going to create a new version here, I am going to be able to collect or add pre-processing and augmentation steps. I'll link in the description about what augmentation and pre-processing really are and deeper dives of why you may want to use them. In terms of pre-processing, I know I only said I'd talk about augmentation, but I'm going to give you a little bit of a couple of hints on pre-processing too. Pre-processing are steps that apply to your training, valid, and test set that basically clean up your images and apply uniform changes to your data set, whereas augmentation randomly apply to the images in your data set and increase the amount of images. Pre-processing is more a one size fits all. So for example, I'll resize all my images to say 416 by 416, and I can fit it with black edges, or I could stretch to that size, which will change the aspect ratio ever so slightly. I'll go ahead and use a stretch for mine. When you have aerial data in particular, one pre-processing step that can help a lot, and we have this in the comments as well, of dealing with small objects is tiling, which breaks your images into smaller subcomponents. So if I made a 2x2 tile out of my preview, I would get this grid image like you can see on the top. I'm not going to apply that step just for today's example. I'm only going to focus on augmentation, but I did want to call that out. So let's go ahead and continue and go to augmentation. Some of the augmentation steps that make sense for aerial data sets are things like flipping. So this could be a horizontal or a vertical flip, which basically creates a mirror image of your image from one perspective or another. That will make sense in the context of this data set. Another one that might make sense here if I want to add an additional augmentation step is a 90-degree rotation, right? Because the camera above could be viewing these boats from any different perspective, which means that the upside down, 90-degree turn left or 90-degree turn clockwise could all make sense. So I'll apply that. Additional ones that make sense. So I might think hue could make sense here where the color changes. This does a color wheel change and modifies the color. I'll do, I don't know, about 40, 35 degrees looks about right, minimum and maximum. And remember, with augmentation, we're setting minimums and maximums. Our images could be up to this amount, not required to be this amount. So getting good bound set is good. I'll do brightness changes. My images could be a little bit brighter, a little bit darker. This makes a ton of sense for aerial imagery because I could have a darker day or I could have a brighter day. So I'll apply that. Let's see, maybe a little bit of blur if I think that like my perspective could be shifting. This is one that will depend on the domain that you're tackling. I'll do just a little bit, a 0.25 pixels amount of blur might apply to the context of my example. Exposure, this is similar to brightness, except it's a contrast change instead of like a uniform filter that gets applied. And I do think that this could make sense for the brightness and darkness of my day, so I'll also apply that for my outdoor conditions. Okay, crop. This is an interesting one. This will randomly zoom in on different portions of my image. This makes a lot of sense in the context of aerial data. Randomly zooming in or out so that you see more or less of the image will make a lot of sense if the objects are near or far. For example, if you're flying at various altitudes, this will help a lot, or if the object could vary in size from below. Let's check a few others. So, I mean, little bits of rotation could make sense. I'm gonna try without initially. Let's see. Shear similarly could make sense. It kind of tugs and alters the perspective of the images below, but I don't think I'm gonna use that or give that a go this time. Cutout, if I think that I'm going to have my images blocked by something on the ground, you can see that, that would allow my model to learn resilience to occlusion. But I'm not going to use that one in this context because I'm going to pretend my model does not get occluded. Grayscale. This is like if, sometimes I don't have color and I don't want my model to memorize the color of things. I'm not going to apply that here. Saturation, I actually do think will make sense. My images could be a bit more colorful, a bit less colorful, and maybe up to negative or minus 40 degrees. And then noise, I'm actually gonna make the bold assumption that I'm not gonna have any camera noise or artifacts. So I'll go ahead and continue. And then lastly, so how big do I want to make this version? I'll say, up to 10x the version size. Now recall, I might not get exactly 10x because we don't generate duplicate images. Duplicate variants, I should say, of those individual source images. But I'm gonna go ahead and generate this. So you notice I'll pick flip, 90-degree rotate, crop, hue, saturation, brightness, exposure, and a little bit of blur. These are the recommendations I would make for almost any aerial data set. When I go ahead and generate that, I'll just call it like V1 aerial. That sounds good. And as that gets generated, we can give it a moment and then dive into looking at some of the examples that were created from our source images. This is the first version that we've generated on this data set on our account, so it's just the V1 version here. Remember, because we did 10x, that means each source image, of which in the training set, so we had 72 overall, and in the training set we had 70% of that 70. Each of those are what's getting augmented. The validation and testing set are remaining their same view. The ground truth is the exact same. So now our training set contains 340 images, whereas before, it only had 52. The validation set is still 10 and the testing set is still just 5. Now let's pull up some of these example images and have a look. And load more. And we'll see here these duplicative images that simulate the real world conditions that we know our drone might see on the ground. So here I can actually tab over here and I can show you this one was made a little bit darker, it was a little bit less saturated, the colors were changed a little bit, and there was a little bit of blur that was added to this one. This one was cropped and zoomed in a little bit, cropped and zoomed in a little bit. So you get the idea. I have a bunch more examples for my model to learn from. So that's awesome. Now from here, I could go ahead and actually train up a model if I like, and see that general model performance. I could even compare that model to my model without augmentation. Go ahead and like and subscribe. I'm gonna kick off a training job and we can see the results once the model finishes training. Thanks.